Hey guys, welcome to lesson 5. This is our last lesson in this unit, and in this lesson we're going to focus on writing equations of trig functions. So the first thing when you come to a problem like this, I want you to ask yourself, does it look more like sine or cosine and why? So kind of think about that for a second. So this one starts at 0 and it goes up and then goes back down to 0, goes down and goes back up again. So this is going to be a sine function. Now I want you to think about the amplitude. So the next step is to think about, look at the dots that I made, and what do you think the amplitude would be? Okay, so notice that it goes up to 1/2 and down to 1/2. This is, so our amplitude is 1/2 in this case, but it doesn't always mean just because it goes up to 1/2 and down to 1/2. The reason why that works is because right here, this is called our axis of wave equation. It's at y=0, so it's at that x-axis right there. And so that's kind of part of step 2 is figuring out, I always call it the equilibrium position. So like, where is your line of equilibrium position? And in this case, it's at y=0. Okay, once we figured out those two things, our last step is to figure out the period of the graph. So what is the time period that it takes to make one complete rotation? So go ahead and figure that out. Okay, so let's go back to what we were talking about. It begins here, goes up and down and back up again. So what is the time period that it takes from here to here? And I covered it up. It's pi/2. So to look at this algebraically, again, we're starting at 0, so it's really easy to see pi/2. But what if we weren't starting at 0? So I want you to kind of think about the formula of period. So let's go back up here. So period is 2 pi over b. And we know from this case, because it's not shifted at all, your period is pi/2. And so we need to find b, because we're going to use that in our equation. So if I cross multiply and divide, I find out that b equals 4. So that's going to be helpful when we finally, in step 5, we are going to, 4, isn't it? We are going to write the equation. So think about A, B, C, and D that we've talked about in our former lessons. We are going to pull from those here in a second. Okay, so y equals A sine of B and x minus h plus k. Okay, so we have our amplitude. We found that. It's 1/2. Okay, we have our b. We found that. It's 4. Okay, was the graph shifted left or right? Was the graph shifted up or down? And it was not. So we don't have to worry about any of that. So our final equation for this graph is going to be 1/2 sine of 4x for y equals. Okay, go ahead and go through the same process here. So the first thing I want you to think about is what kind of function do we have? And see how far you can take this one. Okay, so this is kind of my thought process. It's cosine. It doesn't start at 0. It starts at a negative number. So in this case, it's -3, and it's going down, up, down. So it's going like this direction. So I knew that it was going to be a negative a value. Even though our amplitude is +3, it's going to be negative in our equation. So y equals -3, and again, it's cosine. And so we found, I don't want to leave this out, this equilibrium position or wave of axis equation, that's at y equals 0. So that made it easier to find what a is. The next thing is period. And so I knew that it took from 0 to 2 pi. to get the look that we were going for. And so my period was 2 pi. And so I used my period to figure out what b was, and b in this case is 1. So my answer is just simply y equals -3 cosine of 1x, or just x. Again, there's no shifting left, right, up, or down. So go ahead and see what you notice. This one is going to be a tad bit different. It's adding something new. See if you can find it. Okay, so a couple things. I noticed that this is going to be a sine function. I also know that it's super stretched out. So it's going from 0 to 6 pi. So I figured out what my b was using the equation. I also noticed that the axis of wave equation is still at y equals 0, so we haven't messed with that at all. So my amplitude is going to be up 2 and down 2. So my amplitude is going to be 2, and it's going the right direction. So my a is positive 2. So y equals 2 sine of 1/3 x, because again, it's not shifted left, right, up, or down. If this right here were like y equals 1, then we would put that +1 out there because it's shifted up 1. But we haven't had anything like that yet. Okay, what about if you have an equation like this, or a graph like this, and we're trying to find the equation for it? There can be sine and cosine for all of these graphs. So we're going to talk about shifting, because really, if you just look at a regular sine function, it looks like this because it goes on and on forever. If you look at a regular cosine function, it looks the same way. So there's a possibility of all these actually, but we're going to focus on this one first, having both a sine and a cosine equation. So the first thing we're going to do is find the amplitude. And the thing that's sticking out at me is that it's no longer